Hello everyone, hope you all are doing well. So I am back with another Leetcode Daily Challenge and it is Leetcode number 84, largest rectangle in histogram. And it is an high level problem and I also feel the same. And it is also a must do question for interview, very important question. So the question is given an array of integer heights representing the histogram's bar height, where the width of each bar is 1. Return the area of the largest rectangle in the histogram. Okay, so for example, uh, if you see here, there are some histogram like 2, 1, 5, 6, 2, 3, and you have to return maximum area uh, of the histogram. Okay, means the largest rectangle of the histogram. For example, you can see this is the answer here, 10. I will explain it in a very proper way in the explanation part. Okay, so let's see the constant. The height length can go up to 10 to the power 5, and every element in the height array can go up to 10 to the power 4. Okay, so let's start with the explanation. Let me copy this code. Okay, now here there are some prerequisite. Like you should know how to find next smaller to left and next sorry, smaller to right. Okay, you should know how to find these two thing. Okay, and it is these two are implement using stack, and if you already studied this question, then you can understand this question in a very easy way. But if you don't know this, okay, then you will find it very hard to understand this question. Okay, so this is the must do question, do topics, and if you don't know how to do it, okay, then I will provide some article link. Okay, or you can see some YouTube videos or to understand in a better way. Okay, so I am assuming that you already know how to find out these two thing. Okay, so let's first understand the question. Okay, so my first is, it is first one is length of 2, then length of 1, then length of, let's, it is 5, then it is 6. Okay, then it is again 2, sorry, again 2, then the final one is again it is 3. Okay, this. So if you see carefully, and our final answer is this one, this one. Okay, this bar, which come out to be 10. Okay, so you can see that what we will do, like we have to first of all we have to find out every element next smaller to this left and next smaller to the right. Okay, so if I find out next smaller or to the left, okay, NSL, which I called as NSL, next smaller to left, then you can see here, for this bar, our first bar, you can see it is, the value is 2. Okay, so we need to find out a element which is less than 2 in the left side and also to the next. Okay, so as I told you, if you follow the prerequisite, if you know the prerequisite, then you can understand this thing. Okay, like what is this? So there is no element into the left side, so I will put here -1, and we are putting the indexes. Okay, we are not putting the values, we are putting here, we need to find out the indexes. Why? Because I will tell you after the completion of NSL and NLSR, okay, why we need this indexes. So then we try to find out one. So again you can see that there is no smaller element in the left side which is less than this one. So I will again put -1, as we are going outside of the array from the left side. So we put -1. Okay, then here it is 5. Okay, and the next smaller is the one, oh, the histogram which has length 1. Okay, so it is in the 1 index. Okay, it is also in the 1 index. So here I will put here 1. Then for the 6, the smallest element will be 5 in the left side. Next we have to find out next smallest element. Okay, not the smallest, the next, very next smallest. So we have to take here the 5, so it means it is 2. And then for this 2, the answer is 1. Okay, so the index will also be 1. And for this 3, the next smaller is this 2. Okay, so this 2. Now if I found the NSR for this all elements, so I have to, for finding NSR, you have to start from the right side. So first of all, you see here 3 and there is no element to the right. So what we will push here? -1? No minus 1. We will push the size of the array. Okay, like here it is 1, 2, 3, 4, 5, 6. 6 elements are there total. So I will push 6. Why? So if there is no element, then this is the our answer. And similarly, when there is no element to the left, I have taken this -1. And if there is no element to the right, I have taken this. Okay, 6. So here the 6 is equals to our length. That's why I am putting the length. Okay, so it is 6. Then then again I come to this index 4, which is means this 2 value, and I check if there is any element which is in the which is smaller in the right side. Okay, and there is no element, then again I will push 6. Then I will check for this 6. Yes, there is an element which is at index 4, so I will put 4. Then I will come here and I will see that yes, there is an element, and it is at index again 4, so I will put the 4. Then I will check for 1. There is an element which is smaller than 1. No, there is no element. So I put 6. Okay, because we are comparing from right side. So I will put 6. And again I take a come here and I will check if there is any element. Okay, so as you can see, there is yeah, there is one element and it is at index 1. So I will put 1. Okay, so okay, so this is the NSL and this is the NSR of this. Okay, so you need to find these two thing you need to find only. And now how we will find out? Look, and then we will check for every possible bar. Okay, our correct answer will come in at this bar, which length is at 5, means that second index bar. How? Let me tell you. We will see its next smaller to the left and next smaller to the right. Okay, so you can see that at second index the next smaller is to the left is at 1 index and next greater is at the 4 index. It is correct. Its next smaller is at 1 index and this next smaller it is uh, fourth index. Now what you have to do, you get a width. Okay, you know, now you will able to find you get the width. Okay, so the width can come out to be, so this is the NSR. You have to take the NSR I minus NSL I of that element -1. Why -1? Because you can see that the width is 2, not 3. Okay, so but the difference here come out to be 4 minus 1, it come out to be 3. So we need to reduce by it 1. It is for every histogram we have to do this same thing. Okay, this is the formula for the width. Okay, so you got the width. Let me write it W. And what is the area? It is width into height. Okay, so what is the height of this bar? The height of this bar is 5. So you have to, then the area will be width into height. So my width is here 2. As I do 3 minus 1, it is 2. So it is 2 into what is the height? 5. And it is come out to be 10. Okay, so similarly if you do this same thing for all the element. Okay, let's try to solve all the element so that you can understand in a better way. And so when I have writing these elements, okay, so you see that I have started from right side but I inserted this element from the left side. Okay, from the left side, so we need to reverse it. Okay, we need to reverse these elements, so we have to reverse it. So our final answer will come out to be like our, we need to reverse ns nsr. So then our new nsr is after reversing it is 1 6, or then again 4, then again 4, then again 6, then again 6. Okay, so this is our nsr. You need to reverse the nsr as I am inserting. Okay, so from the left. So this is our final nsr. Okay, now for this example, as I told you, I have 1, then I will take -1 for the nsl, from the nsl, and I will -1. So the answer will come out to be 1 plus 1 2, 2 minus 1 1, and 1 into, as I also need to multiply its side, it is 2, so it will come out to be 2. And if you see here carefully, the maximum rectangle you can get here is of size 2 only. Okay, you can see here. Now okay, so next is 1. Okay, for 1, let's see what is the answer. So it is 6 minus, the NSL value is -1 for this index, and I have to do -1 again. So it is with 7 minus 1, it is 6, and we have to multiply it with again with this sorry, height is 1, and so we will come to be 6. Then our similarly our next value, it's what is okay, so it is 4 minus -1, then again -1, so it is 5 minus, oh sorry, there is no -1, it is only 1. So 4 minus 1, again -1, then it come out to be 2 into, okay, so what is its length? Its length is 5, so 5, it come out to be 10. Okay, then its next element is 4 again, then -2, then -1, it come out to be 1, then I have to multiply it with height, and height is 6, so 6 into 1 is 6. Okay, then next one is 6 minus 1 minus 1, it is come out to be 4 into 2, because its length is 2, height, I means the height is 2, so it is 8. Then again, if you see here, it is 6 minus 2 minus 1, then you will get 3 into 3, which is 9, which is okay. So from all these values you can see this one is the greater one, so our answer will be this one. Okay, so hope you understand this code, and as I told you, you need to understand this nsl and nsr. Okay, next smaller to left and next smaller to right. And as I told you, I will provide this oh, article link in the description, so you can check it out, or you can watch the YouTube video. So let's see the code. Okay, so this is the code. I have find out the nsl and nsr function. Okay, and as I told you, we need to reverse the nsr, so I have reversed it here. So then I call the nsl and nsr, and it will return a left and right vector, okay, of all the value, means all the it's contain all the indexes. Okay, and I just iterate through it, and I the formula for I told you for the width, and we have to multiply with the height, so I have to do the same thing, and I get our maximum answer. Okay, and this code are for nsl and nsr. Please try to understand it, okay, in another video or editorial, because without it, this question is be a blender for you. Okay, so let's submit it. Submit it. So I will provide also this solution link also. So hope you enjoyed this video. So if you do, please like, share, and subscribe to the channel, and see you tomorrow. Okay, so bye bye, keep coding.